Hello, Achievers India. I am Shiladitya Mukherjee, Professor of Computer Science. I will be starting with Semester 1, Computer Fundamentals and Digital Logic, first semester. So, in Computer Fundamentals, first we will be starting with some concepts. After that, we will be moving on to digital logic. So, what do we mean by the different operating systems? So, operating system is a system software on which the different applications run or execute. Over here, we have to understand computer software and hardware. So, we write SW, short form of software, and HW as short form of hardware. Now, over here, software is again divided into two parts. Number one, system software, and number two is application software. So, whenever we deal with a particular software which is a system software, we define it based on the software that is running at the background. That is, in the system there are different system softwares. One of the example is operating system. Now, application softwares, in short, nowadays we call app or apps. So, these apps are installed over the system software, or rather the operating system. Examples of operating system are Windows, Unix, in advanced level it is Linux, or other platforms of Linux. Example are Fedora, Ubuntu, etc. So, application softwares are nothing but the different apps. So, Microsoft Office is the package under which we have the different types of softwares: Word, Excel, PowerPoint, etc. So, as we can understand that hardware is the core over which the different software stand. So, the system software, that is the application software, also resides over the hardware. So, in the base we have the hardware. So, it is defined based on some chips where we have the motherboard, and along with that we have the different cards. So, we can have the SSD card, the RAM card, etc., which can be fit into a particular motherboard. SD, RAM, etc. So all these comprise to form the hardware. So over here we will be interested in the software. So when we are learning with the different types of programs, so the programs will be starting in the next semester, that is second semester. We have the starting with programming in C language, and after that we will be having some forms of database. Next we will be learning something of AI, which is a big boom nowadays. So there we will be learning Python language to have the different projects that form the base of data science and machine learning. Those we will be learning one by one in the different semesters as we proceed with the different topics. So over here today we will be discussing about the basics of the software fundamentals, or rather the computer fundamentals. So in computer fundamentals we have a very good book which you can refer, that is Maurice Mano. So Maurice Mano is one writer, and Introduction to Computer Fundamentals is the heading of the book. Or we can also go for another book whose writer is Rima Joshi. So that is also a very good book, Indian writer Rima Joshi. So there we have the different concepts of the computer fundamentals, and along with that he has included a part of Introduction to C language. So both comprise of one whole book. So that book will be comprising the semester 1 part as well as semester 2 part. That is also a very good book. So over here when we see the different logic, so we are writing in a particular application. So whatever we are doing, so this is the 2 out of 2. That means we are writing in the second page of the note. So we are writing in a note. So we can minimize this. So when we minimize, we see, so this is the desktop of the window. So this is the Windows platform, as we can see, and in the Windows platform the bar below is known as the task bar. Over here these are the different applications that has been loaded, and over here when we just click on any of these it will open. That means we are opening an application. So this is highlighted. We can understand that this note is the application that is running, already running. So the applications can be defined as different processes. So we can define Windows as multi-processing system. That means when we are having this particular note which is running, along with that we can also have another PDF. We can open a PDF, or we can open a Word file, we can open a PowerPoint file. So these are the different examples of the applications that we have. So on the desktop you can see the different icons. These are known as the icons. By looking at any of these icons we can say what type of file it is. All right. So this is a shortcut to McAfee security. This is a shortcut to Excel. So if I click on this, it will open the Excel file. So it's opening the Excel. So when we double click, it's opening an Excel sheet. So Excel sheet is one of the applications. As I was discussing, Microsoft Excel is a type of Office package. So it is under Office package, Microsoft Office package. Microsoft Office is a total package under which we have Microsoft Word, Microsoft Excel, Microsoft PowerPoint, etc. So we can minimize this from the minimize window. So it's minimized. So now we can see that two things are highlighted. Two softwares have been opened. Two application softwares have been opened. As I discussed, there are two types of softwares. One is the system software. The operating system is one of the examples of system software. And application softwares, they are loaded on the system software. If we open Linux, Ubuntu, Fedora, that is also another operating system. So there also we can have different types of application software. So over here we are having the application softwares opened. So we can close the Excel file. Since we are not requiring this Excel file, later we will be using this Excel, we will be working with this Excel file because Excel is also in the syllabus. Okay, so we will be dealing with some of the applications, Microsoft Word, Microsoft Excel, Microsoft PowerPoint, those are within the syllabus, and along with that we will also be doing with some digital logic. Digital logic means we will be incorporating with binary mathematics and how we deal with binary mathematics, which is related to the computer science. So over here we can just open the note again and start with the different types of softwares. We can have already seen what are the different types of softwares, different application software and system software. Application softwares, we also defined the different types of application softwares that we have. So I would like to show you another thing. So over here, when we deal with run, so over here we can open the different application softwares that have been opened previously. Okay. So we can search for a particular topic over here. So as you can see, we can type something over here and we can search for that particular application. Okay. So we write, for example, Notepad. Automatically you can see that Notepad application has appeared, and if we click on that, it will be opening the Notepad. So notepad.exe is an application which opens automatically when we type Notepad and press enter. Alright, so we can easily understand it is actually based on any application will be running if that is of the form of .exe file or application file. So over here we have opened that without saving the file. So if we click on file, we can save that file, or we can also open an existing file. So like this we can have the different menu items through which we can move to the particular menu which we want to have. For example, if you want to open a new file, we can press new or we can have the shortcut key Control N. If you want to open an existing file, we can open that. If you want to save the file, we can save this file, and so on. So if you want to exit, you will be exiting from that notepad. So like this, we can open any application. So let's have a look. Now here we can work with the different types of the languages. So whenever we deal with a programming language, so we can easily understand what is the type of language, computer language, that we want to learn. So first we will be starting with the programming in C language in the second semester. So what is the type of language? So the types of languages can be divided into number 1, procedural language. Number 2 is object oriented language. Number 3 is general purpose language. In the middle, we can have combinations object based language. What do we mean by object based language? Object based language means we can create different objects, but we cannot have dynamic polymorphism for that particular object. So we will be discussing about this later. Just we will be learning about the different types of languages that we can have. Number 1 is procedural language, number 2 object oriented language, number 3 general purpose language. Over here we have the concept of interpreter and compiler over here. Now what do we mean by interpreter? Interpreter interprets the different lines of code one by one. That means if we have any error in a particular line, it will stop there. So after rectifying the error in that particular line, we will be moving on to the next line of code that will be again checked whether there is any error or not. So that is the task of interpreter. That means interpreter does not interpret at one go. The total code is not decoded at once. It is decoded line by line. So if we have any error, we rectify it. Again, we move on to the next line of code. Example of interpreter is basic language, which is actually done in school. In some syllabi, we follow QBasic as or GW basic as the programming language, which follows the procedural language, and it is based on interpreter. So QBasic or GW basic are examples of basic languages which are based on procedural language. That means we call different procedures or functions, and these procedures return some value or may not return some value, and we can work from that particular function to the next lines of code in the main function. We start with a main function, from there we call a particular function, we come back to that main function and follow the lines of code again. So what does that mean? It is a type of subroutine or procedure which may or may not return a value to the main function. We can also have a sub function. That means from the main function we call a function, from that function we can call again 2 or 3 functions. So that is the concept of sub function. So that is based on procedural language. Whenever we have the concept of functions that are called or the procedures that are called, we define that as the procedural language. Now, a question comes often to the little minds that whether a language can be treated as a procedural language as well as object oriented. The answer is yes. We can have a programming language which can simply be defined as procedural language and also as object oriented language. That means the combination of procedural language and object oriented language. Now in C++, we have the concept of procedural language. That means yes, we can only call functions and complete the programming. So that can also be done in C++ language. That is the concept of simple programming language that are incorporated in C++. Or we can also have objects that are created based on C++ classes. We can have a class defined in C++ and we can have different objects based on those classes, and we can create objects of those classes, and based on the objects we can call the different functions defined within these classes. So that can also be done. So C++ can often be defined as a hybrid language, HYBRID, hybrid language, which is a combination of procedural language and object oriented language. Now C++ is not fully object oriented language because the main function resides outside the class. That means it does not follow the property of object orientedness. Which property? Encapsulation. Encapsulation property is somewhat violated in C++, which is actually rectified in the programming language Java. So in Java we have the concept of fully object oriented language where everything is written within the class. Encapsulation is fully followed and it follows all the other object oriented properties. Java follows all the other object oriented properties. So it is often known as a fully object oriented language. Now general purpose language, we have the concept. So here C is, other than this QBasic or GWBasic, we also have C language or ADA. So these are actually the languages which are defined as COBOL. So these are the procedural language. C, Basic, COBOL. COBOL is common business oriented language. Pascal was another language. Previously we used to incorporate the different programming languages, C, Pascal, COBOL, etc., which were based on procedural language. So we have the concept of object oriented language. Object oriented language is C++ can be defined as object oriented language, and along with that we can also have Java as object oriented language. Now general purpose language is Python. It is very easy to write. Now in Java we have the concept of both interpreter and compiler. C and C++ have the concepts of compiler because compilation of the total program is done at once and it provides us with the different errors that we can rectify one by one. So all the errors are given at once, not line by line like QBasic, GWBasic, etc. Alright. So whenever we have the concept of errors that are given line by line, that is the concept of the interpreter. So we move to the next page. Now, whatever be the language, the concept of the programming, the flow of the program can be defined by different steps which are known as steps of algorithm. So what is algorithm? Algorithm is nothing but the steps of the program flow. Steps of the program flow that are written to understand the logic of the program output. We consider one example of the algorithm. Step 1 always will be start. Step 2 input n. Step 3 define I as 1. Step 4 I is incremented by 1. Step 5. So define I as 1. So this is the initialization of I to 1. So I is incremented by 1. Step 5. If I reaches n, then go to step 8. Step 6. That means if I does not reach n, we will be moving to the next step. So we can write also over here else go to step 6, but that is redundant. So we can automatically move to the next step. It is following step by step coding. So after step 5, obviously it will move to step 6 until and unless we explicitly ask to move to some other step. Go to step 8. Step 6, print I. Step 7, over here step 7 is so we do one thing, we make this step 7 because we don't need step 8. All right, print I. So step 7, so if I reaches n, go to step 7. Over here we exit. So what is the implementation of this algorithm? You can also write stop. So it will be printing 1, 2, 3, 4 dot up to n. So that is the logic of this particular algorithm. So we consider input n, define I as 1. So I is initialized to 1 and then I will be incremented by 1 and we will be printing. So it's better to define I as 0 because here since we are incrementing I as I by 1, so we will be starting to print from 1, not from 2. So if we initialize I to 1 and we start incrementing I by 1 over here within the loop, then it will be printing 1, 2, 3, 4, 5, 6 and not from 1. So over here we print I and then we move to go to step 4. That means we again increment I by 1, then check I reaches n or not. If I reaches n, we will move to step 7, else we will be go on printing I. Step 6 is print I. Alright. So after printing I, we will be again moving to step 4. I will be incremented again by 1. So we print I, 1 is printed, we move to step 4, I is incremented by 1, I becomes 2, 2 reaches n, for example n is 5. So whether 2 reaches n, 2 is 5? No. That means we will not go to step 7, we will move to step 6 again we print I, that is we print 2. We go to step 4 again I is incremented by 1, I becomes 3, 3 is 5? No. We again move to step 6, we print I, 3 is printed. We again move to step 4, I is incremented by 1, 4. So 4 is 5? No. Again we do that same step. So until and unless it reaches 5. So when it reaches 5, we move to step 7 and exit. Alright. So we can change a bit in the whole logic and then we can check whether it is printing or whether it is providing us with the correct output or not. So this is what we have, the lines of code that are written in English step by step. So first step will be start and the last step will be exit or stop. That means we are exiting or stopping the program, and within that we have the lines of code step by step. So we can move to the different steps when we are having a loop. So just have a look over here. This particular concept is known as a looping structure. So this is the loop structure that we will be continuing until and unless we are exiting from the loop by an exit condition. So what is the exit condition? When I is reaching n, we are exiting from the loop. So that type of concept is known as a loop, and this if is considered as a conditional statement. Alright. Now loops, when we will be learning the different computer languages, we will be learning the different types of loops: for loop, while loop, do while loop, So these are actually the entry control loop or exit control loop. Those we will be learning in the next semester. For now, you understand what is an algorithm. This is an example of algorithm. In short, we define that as algo. Now, the pictorial representation of this line by line English like structure for the code is known as a flowchart. So what is a flowchart? A flowchart is nothing but the pictorial representation of the program. So what is a flowchart? Algorithm is the step by step English like form representing the whole program. And flowchart is nothing but the pictorial representation of the whole program. So nowadays, whenever we have something, everything is based on the visualization. If you want to see the data of something, so that can be more effective when we visualize that data. All right. So that is what we mean by visualization of data. If we visualize how many students have passed in class 10 in Madhyamik, ICSE, CBSE, so the different boards that we have, what is the percentage of the students who have passed? So this is what we understand very quickly if we visualize that data based on some graph, isn't it? So data visualization is very important in this case. So whenever we deal with the pictorial representation of the whole program, we can easily understand that particular program. Let's have a look how we define the pictorial representation of a program. So example of flowchart of printing the different numbers up to n. Let's have a look how we deal with that program, the same program. Start. What's next? Input n. There is a difference between this symbol oblique rectangle and straight rectangle. Straight rectangle is defined for defining something or declaring something, and oblique rectangle is for considering the input or output of some unique variable or some multiple variable. Over here we are considering the input of one variable n, and then we are defining I as 1, I initialized to 1, or rather I initialized to 0. After that, what we do? We start with a loop. So for that loop, the conditional statement can be represented based on a particular rhombus. Is I equals to n? If I is equals to n, if it is equals to n, we will be moving to the end. So before that, we can write some content, print program over. All right. And if it does not reach n, then what we are doing? We skipped one step. So over here, we can bring this whole thing above. Dot input n I equals to 1 or I equals to 0, we can define I equals to 0, then I equals to I plus 1, then print I and then check is I equals to n. Okay, if I is equals to n, print program over, we come out. So if I is not equals to n, if it is no, then we move back to this particular step, that is I equals to I plus 1 again, then we again print I. All right. So 2 will be printed, 3, 4, 5, 6. If n is 7, then 7 will be printed and then it will come out. Instead of having this particular condition, we can write I greater than n. All right. If I is greater than n, then we will exit. And if I is n, up to n, it will print all the numbers. That is 1, 2, 3, 4, 5, 6, 7. Up to 7 it will be printed. If I is greater than 7, it will come out automatically. So that is the logic. And program over, after that it will write end. All right, or stop or end or exit. It's better to write stop or end. So that is best way to provide the information. We end with the program. So this is a very simple example of flow chart. Now we can have multiple flow charts that can be connected from the previous page to next page or previous program to next program. So this can be connected based on a particular connector. So the symbols of flow chart are very, very important. Let's have a look as what are the different symbols. So this symbol is known as termination. Symbol, either start or stop. So that is the terminal symbol. This one is flow. So we are flowing from start to input n, then to I equals to 0 and so on. Rectangle is for declare or define a variable or constant. Oblique rectangle symbol is for input or output. Yes, no. So this is done for branching. So what do you mean by branching? By branching we mean conditional statement. Conditional statement. So is this understandable? Is this be right? Conditional statement. Branching. So over here we can have, other than the branching, we can lead to the loop. So we have to show the branching, and along with that we have to show this. So this is a loop. So termination or terminal. This is the flow of data that we have. Flow of data. This is declaration or definition of a particular variable or a constant. Oblique rectangle is the input or output. This is the branching or conditional statement, and this is the loop moving back to a particular step. We are continuing with that until and unless we exit from the loop. Other than this, a circle is the connector. This is the connector. And dot 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 is the annotation. Annotation. If you want to write something about a particular symbol, so that can be defined by annotation, dot 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 dot, and then we can write something in the flowchart itself. So that is known as annotation. And connector means if we have a huge flowchart, so one flowchart can be written in one page, we can continue with that flowchart in another page, and that can be done with a connector. We encircle, and within the encircle we provide a number 1, 2, 3, 4, and we can take the number to the next page 1. It continues to the third page, then we can have connector 2, and so on. So that is what we mean by connector. So this is all about the symbols of a flowchart. Please note the symbols very carefully. These are very, very important. That can be represented at any level of the flowchart. All right. So this is a very simple example of the flowchart representing the previous algorithm. What was the algorithm? Let's have a look. The algorithm was start input n, define I is 0, I is incremented by 1. If I reaches n, go to step 7, else print I, go to step 4. We move back to step 4. We are printing I and we are moving back to step 4. I is again increment. The same thing is pictorially represented over here. I equals to 0. Before that we input n, I equals to I plus 1. We increment I by 1, print I. Is I greater than n? Then we will be moving to program over, end the program. We are just writing program over. In the algorithm, we did not write program over. We have added this for making you better understand. And we move back to this particular step, I equals to I plus 1, print I. That means you are moving back to step 4. That was represented as step 4 over here in algorithm. Clear? So we move to the next step. After algorithm and flowchart, we move to a simple program. So program can be represented by any programming language, C, C++. So since we have C program, in the next semester, I will be just writing a very small C program to make you understand. Int I comma n. We are not writing main, etc., etc. Main can be defined as a function. Within that we write everything. Int I comma n, I equals to 0. We can use a for loop or while loop. While I less than equals to n, so here we have to printf enter n, printf enter n, nf %d %n, I equals to 0, while I less than equals to n. That means if I is greater than n, we will come out of the loop. I equals to I plus 1, printf %d \t means it will just give a tab space. I and that's it. Clear? The simple program, C program. We are taking the input of n. Printf is actually a function, system defined function which represents enter n. It will ask the user to enter something for the value of n, ampersand n. N is input. I equals to 0, we add 1 to I before printing I, because we have initialized it to 0. If we initialize to 1, then I is not incremented over here, I will be incremented after the print step. That's simple. So while I less than equals to n, it will continue the loop. If I is greater than n, it will come out of the loop, as simple as that. So it will print up to n. If n is 7, it will print 1, 2, 3, 4, 5, 6, 7. If you take 5, it will print 1, 2, 3, 4, 5 and so on. So that's the simple logic. We proceed to the next topic for today. So since we have already learnt what do we mean by algorithm, that is the step-by-step program flow written in English like language. So you have to write step 1, step 2, step n. Step 1 will be having start, and last step will be having end or stop, exit, anything that we can write. It's better to write end or stop. After that, we dealt with the pictorial representation of the program, that is the step by step or the line of code that are represented pictorially in the form of different symbols that we have just seen. So that was the flowchart. After flowchart, we had a very simple example of the C program. All three are very simple examples that are considered for making you people understand. If you have a complex flowchart, then we have to just follow the steps and pictorially represent the whole thing. Or we can also have the algorithm, the step-by-step writing of English like language in different steps for the program. So that is the algorithm that we have. So after that, I will be discussing about some of the logic which are represented for the logic gates. Now in the next class, since we will be starting with digital logic, so today I will be giving you a brief idea of what do we mean by logic gate and what are the different concepts that we will be having next class. Just within 20-25 minutes, I will try to cover up that. So in digital logic, we will be having the basic concept of logic gates. So how we represent a logic gate, that you will understand. So logic gates can be of different things, just as we saw in the previous algorithm or flowchart or the C program, that we can have or condition, and condition, and a not condition, or a combination of any of these. So when we are having the concept of not, so not means anything negating a particular sentence. It is raining. So if we try to apply a not logic gate over that particular sentence, what will be the sentence? The sentence will be, it is not raining. Or rather, the opposite of it is not raining is, it is a sunny day. But that cannot be defined directly based on the not gate. Not gate can be applied over the particular sentence or a particular logic. We cannot write the opposite sentence. That can be done with respect to the connection of another rule book where the rule book consists of different statements opposite to another set of sentences. So that can be connected, and there we can represent a particular sentence that can be not implementation of one sentence. So for example, I will take an umbrella if it is raining, but I will have to define, I will take an umbrella or a raincoat, checking whether it is raining and we are having a storm along with the rain. So that defines a particular AND gate. That means we are taking an umbrella and we are taking a raincoat, checking whether it is just simply raining or along with the rain we are having a storm as well. So that is the AND gate that we are applying over two different sentences, defining two different logics, and we are applying the AND logic gate for adding the two sentences. So over here we will be having the AND gate represented over here. And OR means when we are having either or concept. We will have Chinese food or North Indian food, any of these. That means if any of this is present, then it will not matter. So that is the logic. That means if we consider any of this, if K is 1 or rather we write K is divisible by 1 or K is divisible by itself. So what does that mean? So here we have applied OR logic gate. So what do we mean by this? Implies. What does this imply? K is prime, isn't it? So if K is divisible by 1 or K is divisible by itself, any of these two, then K is prime. Now when we define AND gate, that means both the conditions have to be satisfied, must be satisfied. So where do we apply AND? If it is raining and it is a storm, then means this is actually the output. Then we take a raincoat. So that is the concept of AND gate, AND logic gate. So AND logic gate is a concept when we are considering both the statements to be positive. It is raining and it is a storm. Then we will be having a raincoat. Now we can have if else condition. Else, if it is only raining, we will take an umbrella. Else, we will not take anything. If it is not raining, we will not take anything. It is sunny. That means it is sunny, or it is simply not raining. So, or and not get is, if it is not raining, we will not take an umbrella. Here, so that is the not gate, not logic gate that we are applying. So, any of these three logic gates can be represented with two universal logic gates, NAND gate and NOR gate, not and not or. We will be having the concept of NAND and NOR logic gates, the universal gates, in the next class. So, before that, we come to the last topic of today, that is the concept of the flip-flops. We will be having the detailed concept of flip-flop latch later, after binary mathematics next class. So, today we will be just having a brief idea of flip-flop. Actually, we have the concept of flip-flop which have marked the stepping stone towards the concept of 1 and 0 represented in computer. So, in previous days we had the concept of hardware, where we had the flip-flop representing either 1 or 0, combination of 1s and 0s, meant for one flip-flop representing 1, one flip-flop representing 0, and so on. So, we can have two types of flip-flops which can be represented as JK flip-flop and SR flip-flop. JK flip-flop is generally known as the master-slave flip-flop. It is having the concept of master-slave. So, K is considered as king and J is jack. That has come from the 13 card system, king, queen and jack, K, Q, J, and after that we have the set of different numbers that we have. And SR flip-flop is set reset flip flop. So set reset as in Q is the output and Q bar is the opposite of the output. So this is actually, if it is 1, this will be 0. If it is 0, this will be 1, like this. Now over here, J follows K, because J is Jack, slave. Slave always follow the king or master, in other words. So slave always follows the master. So we will have different concepts of these flip flops, and we will be representing different flip flops having the idea of the concepts of what is latch, difference between latch and flip flop. So as a whole, what did we learn today? We learned the concepts of hardware and software. What do we mean by hardware? The hardware is nothing but the concept of the different chips, RAM cards, the different types of memory cards. Memory is also one of them. So when we talk about the von Neumann architecture is nothing but the concept of computer, input, output and memory. Within that we may also have the different types of registers. So there we have the concept of hardware and software, as in the different types of softwares. System software is one example is operating system, and over here we have the concept of application software as well. Application software always reside above the system software. After that we have learnt the concept of algorithm, so in case of softwares we also learnt the processes that are running. So based on Windows, Linux, so multiprocessing system. What do we mean by multiprocessing system? I have also shown by minimizing this particular window and having the concept of multiple processes running at once. So that is actually in case of round robin system. That means we can see this process, we can see another process if we minimize this and maximize that application. So like this we can have the moving from one process to another process in the run. After that we learnt algorithm, flow chart and a simple program. Program we will be learning in the next semester, so we will not concentrate on program as of now, but algorithms and flowcharts are important in this particular semester. So we had examples of all of them. At the end we had the concept of logic gates, and or not, and we also defined that we have the concept of universal gates, as NOR and NAND, that we will be discussing next class in detail. and also we depicted the flip-flops. This will also be discussed in detail later. So this represents actually ones and zeros that we already defined. So how ones and zeros? That we have already given one example, that 1 not of 1 is 0. In other way round, we can have a combination of ones and zeros, and sum of ones and zeros will be representing a set of bits 1 0 1 0 1 1 0 1, for example. So over here what we can say is we can have a byte. So this is the concept of byte, 8 bits, and each bit represented within a box. So this is the concept of a byte that we will be representing in the next class in detail. Okay. So this is all that we have covered today. So next class we will be starting with a bit of binary mathematics and digital logic. Is it clear? So today we complete with the first class. Thank you.